What's up, class? It's me, Mr. Harris. Today we're going to learn about atomic mass. So here's your objective. You will be able to use the atomic and mass number to calculate the number of subatomic particles per atom. Write that down. All right. So remember, atoms have three subatomic particles. They have they have protons, which have a positive charge, neutrons, which have a neutral charge, and electrons, which have a negative charge. All right, now I would like to introduce you to one of the most amazing tools of all time, the periodic table. The periodic table is the most important tool in chemistry. So basically, there are 118 different types of atom, and all of those different types of atoms are found on the periodic table. It's basically just a chart that shows you all of the different types of atoms. Now, if you look in every box, you can find three different things. So if you look on one box in the periodic table, like this box is the box for carbon. There it is right there. All right, so it has the name of the atom in it, carbon right there. It's got that big C, and that's the symbol for carbon. It's got the atomic number, which is 6, and it's got the atomic mass, which is 12.011 AMUs. All right, so the atomic symbol represents the element. The first letter of an atomic symbol is always capitalized. If there's a second letter, it's always lowercase. This is incredibly important for later. All right, now the atomic number is the number of protons in an atom. So if you look at carbon, its atomic number right here, carbon has 6 protons. And you know for every proton there's an electron, so it's also the number of electrons. And it's got the atomic mass in AMUs. So the atomic mass is 12.011 AMUs. That's how much carbon weighs. Now we're going to look at nuclear notation. Sometimes scientists give us an abbreviated version of what is on the periodic table. It's called the nuclear notation. It's just the way to write it without having to draw the box on the periodic table. So here's how it works. You've got the atomic symbol right here. This is He, that's helium. Then to the left and above, you write the mass number. And then under the mass number, you write the atomic number. That's it. Nuclear notation. All right, now let's do this right here. Here's some practice. Mass number versus atomic number. So these are all nuclear notation of different elements. This one is lithium. This one is carbon. Ag is actually silver, the element silver, and Ti is titanium. So just the ones that are on top are the mass number. So lithium, there you go, 7, lithium, atomic number 3. Likewise, carbon, 14, it's on the bottom with the number 14 is on the top, and in this chart it's on the bottom, 14, 6, etc., etc. You can figure that out. All right, the number of particles. So to find the number of protons, look at the atomic number. To find the number of electrons, also look at the atomic number. To find the number of neutrons, subtract the atomic number from the mass number. So here we go. So we look at helium again. Helium has 2 protons. We know that by looking at the atomic number. It has 2 electrons. We know that too because it's the same number of protons. And we know it weighs 4. So now we're going to figure out the number of neutrons that one helium atom has. So all you do is just 4 minus 2 equals 2. That's it. The weight is 4, the atomic number is 2. Now we know how many neutrons it has. 2. All right. I don't know if you guys can see this blue. In any case, draw this chart and fill it in protons, electrons, and neutrons for lithium, carbon, silver, and titanium. Top, you do protons, then you do electrons, and then you do neutrons. This should take you a little while. Pause the video, fill in the chart. Alright, so isotopes are atoms with the same number of protons but different numbers of neutrons. Different amounts of neutrons means different mass numbers. So isotopes of chlorine. So there's chlorine with 35. Oh, with the atomic number of 35. I'm sorry, the atomic weight of 35 and the atomic number of 17. But then there's also atomic weight of 37 chlorine, the same number with the same atomic number. They have different numbers of neutrons even though they're both chlorine. Those are called isotopes when the same element has different numbers of neutrons. Write that down. Isotopes, same element, same number of neutrons. Here's some isotopes. So isotopes are chemically alike because they have identical numbers of protons and neutrons. Look at that, there's different types of neon, okay? So here are some practice problems. Just do these. Answer 1, 2, 3, 4, and 5, and you don't need to write down the questions. All right, you're going to use the periodic table to figure this out. You can look up a periodic table at periodictable.com. All right, thanks very much for watching. Take care.